All right, hi class. In this video today, we're going to be looking at specifically how we can take shapes on the coordinate plane and perform horizontal and vertical reflections. So we're going to be creating some mirror images of the shapes we're looking at. And I'm just going to show you by example. We're going to do 4 different examples and take a look at how this whole process works. So let's go ahead and get out our graph here, and we'll start by just drawing a triangle, and we can call this triangle ABC. So I'm going to put point A right here, point B here, and point C right here. So this will be our initial triangle. So for our first example here, let's do a reflect triangle ABC over the x-axis. Okay, so we've got triangle ABC, and we're going to reflect it over the x-axis. And you want to remember, of course, that this is the x-axis and this is the y-axis. Now, doing over a reflection over the x-axis is as simple as just measuring the distance from the x-axis to every point. So if we look here at point A, I can see that point A has coordinates 3, 2. So the distance from the x-axis is 2 up. To reflect it over the x-axis, I'm just going to put a new point, 2 down. So I'm just taking that point, going the distance that I went up, but now I'm going that distance down. So this is a vertical reflection over the horizontal line. So our new point we will call A prime. That prime just says, hey, this was our original, this is our new one. For B, B has coordinates 9, 2. So new coordinates will be at 9, -2. Again, we're just taking that distance that we went up and going down instead. And you can do this with any point, no matter where they're positioned. If you're doing a reflection over the x-axis, you just measure the distance to the x-axis and go to the other side. So if our triangle had started on bottom, we'd be flipping it up top, or maybe it could even be overlapping it and it would flip like that. Now in this case, our triangle is up here in the first quadrant, so we are flipping it down into the fourth quadrant. Now for point C, we are going to measure up. We're at 1, 2, 3, 4, 5 up. So we're going to come straight down. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. So this is C prime. So our new triangle, triangle A prime, B prime, C prime, is right here. It's just been reflected straight over the x-axis. Okay. Let's use the same triangle, but for a second example, instead of going over the x-axis, let's go over the y-axis. All right, so I'm going to just erase this. This here is our y-axis, of course. So now, instead of doing a flip like this, we're going to take this triangle and flip it over the y-axis. So in this case, you want to measure the distance to the y-axis to each point. So A is 3 to the right here. We're going to keep that same up and down, still 2 up, but we're going to go 3 to the left, and this will be our new point, A prime. For B, it's still going to be 2 up like it is, but we're going to go to the left 9. Since we originally went to the right 9, now we go to the left all the way over to 9, and this is our new point, B prime. C, same thing. It was up 1, 2, 3, 4, 5, so our new point's going to be up 5. We went to the right 5, 6, 7, 8. So we'll go to the left 5, 6, 7, 8, and up 5. So our new triangle, A prime, B prime, C prime, looks like this. It's just been flipped right over the y-axis. And of course, reflections are isometries, so these two triangles are totally congruent, which is a nice thing. So we've done reflections over x-axis, reflections over y-axis. There's a couple other vertical and horizontal flips that you should be aware of. So I'm just going to erase what we've got here. Let's say, let's draw a new triangle, and this one I'm going to draw, let's see, we'll call it DEF. We'll put D here, E can go right here, and F can go right here. So we have triangle DEF. And let's say for this example, we want to reflect triangle DEF over the line y equals 2. So an important thing for being able to solve these kind of problems is being able to know what is the line y equals 2. Where is it? What does it look like? Well, I know y equals 2 is a point right here on my y-axis, and y equals lines are always horizontal. So it's going to be a horizontal line that goes through that point. So I'm just going to draw a nice horizontal line in green here. Okay. And this will be a vertical flip where we're going to take this triangle and flip it over this line we've just drawn. The process is exactly the same as it was before, except for now instead of measuring the distance to the axis, we're just measuring the distance to our line. So this point E here is 2 units above our line, so I go to my line and I just drop 2 units below. There's my new point E prime. My point D was 3, 4, 5, 6, 7, 8 above that line, so I come to the line, and again, not from the axis, but from the line, I'm going to count 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And here is D prime. Same thing with F. F was 3 above my line, so F prime will be 3 below my line. It's all about matching those distances. All right. So we've done over the x-axis, over the y-axis, we've done over a horizontal line such as y equals 2. This would work for any horizontal line, y equals 5, y equals -6. You just put that, whatever y equals, you put a horizontal line at that point and then measure the distance and reflect over. Let's use our same triangle here, only this time, let's reflect over a vertical line. So let's do over the line x equals 7. So a x equals 7 line, and that is a 7, x equals 7 is going to be a vertical line because here's my x-intercept at 7, and I need all the values on that line to be x is 7. So I'll draw a nice vertical line at that point. And again, same process as on all of these. We just measure the distance from our point to our line. So F is closest, so we could start with that 1, 2, 3, 4 away. So I'm going to go 1, 2, 3, 4 over here. And here's my new point, F prime. E is a little bit farther, 4, 5, 6, 7, 8, 9, 10 away. So I come over here and I got to go 10 to the right, and I might have ran myself out of space. Let's see here. 3, 8, 9, 10. Oh, it just barely fits. Oops, but I did drop it down one. Let's see. Should be right there. There's my new point, E prime. Make sure you're labeling your points with these primes because we need to know that this is our pre-image and this is our image. So this is what we started with, this is what we're ending with. Let's see here. For D, I am over 2, 7, 8, 9. So 9 over. My new point D prime is right up here. Connect the dots. And you've got your reflected triangle. So there you have it. Horizontal and vertical reflections. Thanks for watching.